So we have 7.5a, which is solving radical equations. And our objective today with that is to solve radical equations and check for extraneous solutions. So the extraneous part might seem a little bit scary, that word. What extraneous means is that you get a solution to the problem, but if you substitute it back in, it actually makes the equation untrue. So it's basically just an extra solution that would not, excuse me, end up being true. And so this information, these types of problems, can be found on page 388. So let's take a peek at our first problem. I have 7 plus the square root of 2x minus 1 equals 10. Now, your number one goal, the first thing that you have to do, is you have to isolate the radical. That means that nothing else should be on the same side of the equal sign as that radical. So if you notice the 7 right here, that needs to be moved. So I'm going to subtract 7 from both sides. So now I'm left with the square root of 2x minus 1, and that's going to equal 3. And so now this is isolated. Okay, so again, the first step is to isolate the radical. So now what I'm going to do is I have to ask myself, well, what undoes a square root? Like, for instance, this 7 was positive and I subtracted it from both sides. I undid it, the inverse operation. And so the inverse operation with a square root is actually to square it. So I'm going to square both sides because a square root times itself is whatever's inside the square root. So what I'm going to have here is I'm going to have 2x minus 1, and that's going to equal 3 times 3 is 9. So now what I have to do is isolate the variable. So I'm going to add 1 to both sides, and I get 2x equals 10, and I'm going to divide both sides by 2, and I'm going to get x equals 5. Now before I say, oh, that's a solution, we're good to go, I need to check it. So in the check, what I'm going to do is I'm going to rewrite the original problem. However, instead of x, I'm going to put what I got as the solution, which was 5. So then I have 7 plus the square root of 2 times 5 is 10 minus 1 is 9, and that equals 10. The square root of 9 is 3, and 7 plus 3 does equal 10. So therefore 5 truly is a solution. If this did not work, if that was not equal, what would happen is you would have no solution because the only thing that you got for x was 5. And so therefore that would be your only option. And so if it was an extraneous solution, meaning that we got it as a solution but it did not actually end up equaling, then it would be no solution. But we're good to go. So the answer of x equals 5 is correct. It is expected that you show your work and that you also make sure to check it. Let's look at our second problem here. So I have the square root of 2x minus 1 equals x minus 8. And if you notice here, remember, number one, you must isolate the radical, okay? And that radical is already isolated. Nothing else is with that radical, so we're good to go, okay? So now, again, I'm going to do the inverse of square rooting, which is squaring. And so I'm going to square both sides. So squaring the square root of 2x minus 1 is going to be 2x minus 1. Now you have to be really, really careful with this next piece. A lot of times we like to do our exponent rules where, ooh, I just distribute and we're good. Not so much. This is a binomial, okay? So that you have to treat separately. You have x minus 8 times x minus 8. You can't just distribute that exponent. So it's very, very important if there is ever an addition or subtraction sign within it, within those parentheses, that is, more than just a monomial. You cannot just distribute that exponent. So now, what I'm going to do is I'm going to go ahead and distribute that. So when I do that, now I'm going to not show everything with the distribution. I end up getting x squared minus 16x plus 64. So again, if you're going through and distributing it, you get x times negative 8 times x, and negative 8 times 8. I went ahead and just combined them already, so that's what you're seeing there. So you might have one more step than I do in this. So now what I notice is that I have an x squared. Anytime I see an x squared, we need to make sure to move everything to one side of the equation and have it set equal to 0. So what that means is I'm going to move this 2x and I'm going to move the 1 over. So that way I have a 0 here. So then I get x squared minus 18x plus 63. So, I lied, sorry, that's 65. Now what I'm going to have to do is I'm going to have to factor. So if you thought that you never would have to factor again, you're definitely not correct, because you need to be able to factor this. So I have 0 equals x squared minus 16x plus 64. So I'm going to do my little x method. Remember, b goes up here. A times c goes down here. Oh, why did I write 64 here? Lord have mercy. That should be 65. And this should be an 18. I am losing it. So that should be an 18x. That should be an 18 there. My bad. So you have your b up at the top. You have your a times c at the bottom. Remember, you're trying to find two numbers that multiply to be 65 and add to be negative 18. And that then would be negative 13 and negative 5. And so because a is 1, I can do my shortcut of just having x minus 13 and x minus 5, just taking these two values and putting them into the binomial. Remember, if a is anything other than a positive 1, you can't go about it that way. And so now I'm going to set both of these equal to 0 to solve. So I get x equals 13 and x equals 5. Now, I need to see if they work, okay? So I'm going to have to check it. And the very important thing is you have to check it with the original, okay? So I have to go back. Oops, wrong. I have to go back. This was my original here. That's what I have to use to check. So I'm going to have the square root of 2 times 13 minus 1 equals 13 minus 8. Oops, why did I just write a 5 there? That was weird. 13 minus 8. Oh, I know, I did that because I had already done 13 minus 8 mentally. So I now have the square root of 2 times 13 is 26. And 26 minus 1 is 25. And 13 minus 8 is 5. So the square root of 25 is 5. So 5 equals 5. So 13 is a winner. That works. That is a solution. Now I need to check for that 5 solution. So I'm going to have 2 times 5 minus 1, and that equals 5 minus 8. Okay, so 2 times 5 is 10, minus 1 is 9. 5 minus 8 is negative 3. Square root of 9 is 3. 3 does not equal negative 3. Therefore, 5 would be considered an extraneous solution. Okay, so it is, while I did get 5, like we solved this problem, we did nothing wrong, we got x equals 5. However, when I actually substitute it back in, it doesn't make a true statement here. So because of that, it is an extraneous solution. I cannot include it in my solution set. So only x equals 13 is a solution. I have a few more problems to look at that we can look at in that next video.